Welcome to Cosmic Compass, the place where we explore the wonders of space astronomy and the mysteries of the universe. Every world has a story to tell, and together we uncover those hidden tales, one discovery at a time. Today, we're turning our gaze toward the moon. At first glance, it may seem familiar, even ordinary, but beneath its grey surface lies a secret that has baffled scientists for decades. Let's begin our journey. The moon may look like a silent grey sphere in our night sky, but hidden upon its surface are colossal structures that should not exist. Two massive domes rise above the ancient plains, resembling volcanoes here on Earth. And yet the moon has no plate tectonics, no oceans, and no active geology as we know it. So how did these mysterious giants form? Today, we are going to explore one of the strangest puzzles of lunar science, the Gruithuisen Domes. By examining breathtaking images captured from orbit, and by comparing them to what we know from Earth, we will uncover what makes these features so unique and why they may completely rewrite what we thought we knew about the moon. To understand the mystery, we first need to look at the spacecraft that revealed it in such detail, NASA's Lunar Reconnaissance Orbiter, or LRO. Launched in 2009, this mission has been tirelessly circling the moon, sending back an enormous flow of information. Equipped with a high-powered camera, the LRO captures the lunar surface in stunning resolution. Every day, it transmits up to 155 gigabytes of data back to Earth. That's the equivalent of thousands of high-definition films, all dedicated to revealing the hidden features of our nearest celestial neighbour. To put this in perspective, New Horizons, the probe that flew by Pluto, took nearly 2 years to return its entire dataset. LRO achieves the same volume in a single day. Even more impressively, the orbiter is still active more than a decade later. Thanks to its relentless scanning, we are now able to study the moon with a level of detail once thought impossible, from its vast craters to its most puzzling volcanic remnants. Let's focus on one of these strange features. At first glance, the image might appear ordinary: two rounded craters, similar to thousands of others that scar the moon's face. But as we zoom out, the true picture emerges. These craters sit on top of a massive dome known as Mons Gruithuisen Gamma. Look closely and you'll notice how the sunlight glints off the dome's steep western slope, while deep shadows fill the craters. Shadows on the moon appear darker than those on Earth, since there is no atmosphere to scatter light. Without that scattering, the lunar night is nearly absolute, with only faint reflections from the surface providing illumination. In fact, the moon's overall brightness is lower than you might think. Its average albedo is about 0.12, roughly as dark as wet soil. Now consider the sheer size of this structure. Mons Gruithuisen Gamma rises 1,500 meters above the surrounding plains, with a base stretching 20 kilometers wide. That's the scale of a mid-sized city sitting silently on the moon. Encircling it is a darker, flatter terrain formed by ancient lava flows. Around 4 billion years ago, vast floods of basalt spread across the lowlands, filling craters and valleys like melted chocolate settling into the cracks of a wafer cone. Zooming out further, another dome comes into view, Mons Gruithuisen Delta. This one is even larger than its twin, climbing 1,800 meters high and measuring 27 kilometers across. Both domes rise from a vast expanse known as Oceanus Procellarum, or the Ocean of Storms. Covering over 10% of the lunar surface, this plain of dark basalt is one of the most prominent features on the moon. When seen from orbit, the domes look like islands rising above a frozen ocean. It's a beautiful, haunting image, one that captures both the stillness and the mystery of the lunar landscape. But what are these domes? To answer that, let's turn our gaze back to Earth. In the Pacific Northwest of the United States stands Mount St. Helens, an active stratovolcano that erupted violently in 1980. Its slopes, shaped by slow-moving, silica-rich lava, form dome-like structures remarkably similar to the Gruithuisen Domes. Unlike the broad basalt flows that form smooth lowlands, silica-rich lava is thick and viscous. It oozes instead of rushing, piling up over time to form steep-sided cones or domes. The Gruithuisen Domes seem to have been created in the same way, with highly silicic material slowly extruding from beneath the lunar crust. Recent thermal measurements from LRO's instruments support this idea. They suggest that the domes have a different composition from the surrounding plains, pointing towards silica-rich materials like rhyolite or dacite, the same kinds of rock found in stratovolcanoes on Earth. Here's where the puzzle becomes even stranger. On Earth, stratovolcanoes and silicic lavas are closely linked to two things: water and plate tectonics. When one tectonic plate slides beneath another, water-rich rocks are thrust into the mantle. The remelting of this material creates silica-rich magma, which then erupts to form domes like Mount St. Helens. But the Moon has neither liquid water nor plate tectonics, so how could such silica-rich material exist there? Scientists have proposed two main theories. The first is known as fractional crystallization. As basaltic magma cools, different minerals solidify at different times. The leftovers, the residual liquid, could become enriched in silica. Think of it like cooking a soup that reduces down until only a concentrated broth remains. In this case, the broth would be silica-rich magma. But there's a problem: this process typically produces only small amounts of silica, nowhere near enough to build domes as massive as Mons Gruithuisen Delta. The second theory is partial melting. Imagine hot magma from deep inside the Moon, rising up and heating the rocks above it. Those rocks could partially melt, creating silica-rich magma in the process. If this were true, the domes might be roughly the same age as the surrounding basalt plains. Future studies will need to confirm whether that's the case. Both ideas provide possible explanations, yet neither fully solves the mystery. And that's what makes the Gruithuisen Domes so fascinating. They should not exist under the Moon's conditions, and yet they do. Fortunately, we may not have to wait too long for answers. NASA plans to send a commercial lunar payload services rover to this very region in 2025. The mission will be tasked with exploring the domes, directly capturing close-up images and collecting rock samples. By analysing these materials, scientists hope to determine how such silica-rich structures could have formed without water or tectonics. The results could reshape our understanding of not just lunar geology, but planetary volcanism as a whole. High-definition images from LRO will guide the mission, helping engineers choose a safe landing site. For the first time, we may soon stand on the threshold of solving this lunar enigma. So, what do we make of all this? The Gruithuisen Domes are silent, towering witnesses to a volcanic past we still struggle to explain. Their presence challenges our assumptions about how planets and moons evolve. Are they the result of exotic processes unique to the Moon, or echoes of geological forces we see here on Earth? In just a few years, we may finally hold the answers in our hands. Until then, these domes remind us that even our nearest celestial neighbour is far from fully understood. The Moon might appear quiet and lifeless at first glance, but when we look closer, it reveals itself as a canvas of cosmic art, each crater, plane and dome a brushstroke in a story billions of years in the making. And now, we'll turn the question over to you. Which explanation for the domes do you find more convincing, the leftover concentration of silica from cooling magmas, or the partial melting of lunar rocks? Let's hear your thoughts. Thank you for joining us on this journey. If you'd like to continue exploring the Moon and beyond, check out our playlist for more cosmic stories. And if you enjoyed this video, consider subscribing and supporting Cosmic Compass. We'd love to have you on this adventure with us. Until next time, let's keep exploring the universe together. Space is full of mysteries waiting to be uncovered, and the Gruithuisen Domes are just one piece of the puzzle. As we continue to learn more, each answer brings new questions, and that's what makes exploring the cosmos so exciting. If you enjoyed this journey, don't forget to subscribe to Cosmic Compass for more stories of planets, stars, and the vast universe beyond. Share your thoughts in the comments, and let's keep the conversation going. Until our next voyage, keep looking up, because the universe is always guiding us forward.